So this video is should be a quick video on logarithms, a little bit more in-depth look at logarithms. I talked about evaluating logs in the previous video, but just want to run over that again. So again, the idea of a log is this is the base, over here is the exponent, and then the thing you're taking the log of is the answer to an exponential problem. So, and we can always write these in their exponential form. So like this would be 3 to the what power equals 9. And of course that means this would have to be squared, or 2 I mean, because 3 squared is equal to 9. This is asking 4 to what power is equal to 1/16. Well, we know that 4 squared is 16, but since 16 is in the bottom, this must be a -2, because 4 to the -2 would be equal to 1/16. Okay, and this one's tricky. So we're saying 8 to what power is equal to 2. Well, the only way I can go from 8 to 2, notice it's not a fraction, so it's not a negative exponent. It's actually getting smaller. So we have to think about roots. And if you think about it for a moment, you know that the cube root of 8 is 2, because 2 times 2 times 2 is equal to 8. So remember the way we write roots is with a fractional exponent. So the answer to that would be 1/3. So there's some examples. There are actually a whole page of these on Canvas that you can download and just practice doing that. And I'd advise that you do that. So now the other part of this, which is an important thing, is just like we had rules in exponentials, the way you multiply powers, divide powers, and take a power to a power. So for example, we all know that when we multiply x squared times x cubed, that's equal to x to the 5th, right? Because this means x times x, and that means x times x times x. So really there's 5 x's multiplied together there. So what ends up happening, if you notice, it's a shortcut. You can just add the exponents when you're multiplying powers. Likewise, when you're dividing powers, like x to the 5th divided by x squared, again, this is x over x times x, and those x's will cancel out, leaving x cubed. But notice also, if we would have just subtracted 2 from 5, we would have got a 3rd power. So when you're multiplying a power times a power, you can just add the exponents. When you're dividing a power by a power, you can just subtract the exponents. And finally, if you raise a power to a power, like that, so this means x squared times x squared times x squared times x squared times x squared. There's 5 of them there, right? So if you add all those up, add the exponents, that would be x to the 10th. So when you're raising a power to a power, you would multiply them. Okay. So now, because logarithms are essentially the answer to a logarithm is an exponent, there are some logarithmic rules that apply to each one of these. So, for example, this one would apply to, for example, if I'm taking the log of x times y. So remember in the log, when you're writing a log to an exponential, when you're changing an exponential form, the base is here. This is the power, and the answer is the exponent. So really what we're doing here is we're multiplying 2 powers again together. And that means that I would add their exponents. So another way to write this would be log of x plus log of y. Okay? So that's the first log rule, that you can rewrite log of x times y as log of x plus log of y. Okay? And likewise, if I have a log of x divided by y, that's the same thing as log of x minus log of y. And that, of course, corresponds to that rule there. And finally, if I have log of x raised to the y power, that's like a power raised to a power. So that means I would actually multiply the exponents. And since x is an exponent, and y is an exponent, and log of x is an exponent, you could rewrite this as log y times log of x. And these are all useful powers that are rules that we will use going forward from here. So these are really, really important. You want to put a star by them, memorize them, use them. Maybe write them out on a piece of paper, have them in front of you when you're doing homework from here on out. because you're going to use these and you want to be able to spot them. So for example, if I was sitting here looking at, let's see, log of, here's an example where one of these rules might come in handy. So notice I have a log of 20 plus log of 5. I don't know what the log of 20 is off the top of my head. I don't know what the log of 5 is off the top of my head. But I could rewrite this, if I use that first log rule, I could rewrite this as log of 20 times 5, which is the same thing as log of 100. And remember, if I write log without a base, that means log base 10. So this I can do in my head. This is 10 to what power equals 100? So that'd just be 2. Okay? By the way, I just want to mention that I use log base 10 for all these rules, but any log base anything, well, these rules work. So you could have done also the natural log of xy is equal to the natural log of x plus the natural log of y. Or log base 2 or log base 5, they're all, these rules apply to all of them. Okay? And in the next video, I will show you how to solve logarithmic and exponential equations, and we'll be using these log rules quite a bit in there. Okay? I think there's a couple homework assignments that give you something crazy like this, like log of x plus log of y squared minus log of z or something like that. And they say to write that in just as one log. And so again, you want to look at this and go, okay, well, this right here, if I look at just these two, that's the same thing as log of xy squared, right? And so this, of course, I haven't done anything with this yet. And then I look at that and say, well, that log of something minus log of something, I could rewrite that as log of xy squared divided by z. And so that's, I took this big long expression and wrote it as just one log expression. And of course, you should be able to go the other way. So if I say log of x y squared, and they ask you to expand that out, so you could rewrite this as log of x plus log of y squared. And actually, you could write that, log of x, the same, but write this as 2 times log of y. So when they say expand it out, that's what they mean, is use the log rule to write this in a different way.